Okay, let's talk about my problem, okay? It is really simple process, okay? We're gonna apply the Laplace transform both side. Then we will use the lifting and solve for y of s and inverse Laplace transform, okay? This is big picture, okay? Here we go. Let me apply Laplace transform here. Here is Laplace transform of y double prime plus y equal to Laplace transform of your right hand side, which is delta function times sine t. Okay, and for the first one, we will use the lifting. It is s squared ys minus sy0 and minus y prime 0. The second one is just simply ys. And look at right hand side. When you look at the table, number 17, there's no function, right? Well, wait a minute. Let me come back to the first page of this section. You just follow me. There we go. This guy. Well, I just realized we don't have this one on the table, but we can use this, okay? Look at that. Laplace transform of delta function with t minus t0 f of t is equal to e to the minus s t0 is same part, but you have to multiply f of t0, okay? So we're gonna use this one, okay? Equals number 5. There we go. Let me write here, okay? Number 5, it was Laplace transform of delta function with t minus, let's just see, okay? F of t is equal to e to the minus cs times f of c. We're going to use this guy, okay? Then right-hand side will be e to the minus pi over 2s times sine of pi over t. We know what this guy, right, is equal to 1, okay? Then, okay, and also simultaneously we can apply the initial conditions. This is 1. And this would be, let me gather ys term only, then ys times s squared plus what we have on the left-hand side. And this guy, this was -1, and we're going to move to right-hand side, okay? Is equal to e to the minus pi over 2s plus 1 now. Is that okay so far? Okay, and let me divide by s squared plus 1 on both sides. Then your ys is equal to e to the minus pi over 2s plus 1 over s squared plus 1, okay? So, okay, let's do separate two fractions, okay? Then let me write 1 over s squared plus 1 first, okay? 1 over this first, and let me write e to the minus pi over 2s times 1 over s squared plus 1. I think this is better, okay? So let's say this guy is HS. You know what I mean, right? Like we practice a lot about this part, okay? And then we're gonna find the inverse Laplace transform direct, okay? So this one, when you look at your Laplace transform table, that's exactly the case number 5, okay? Let me write number 5 here, okay? Is Laplace transform of, again, you have to practice a lot to use the table, okay? It was A, right? A over, okay? So keep that in mind. You have to make sure numerator and this guy must be same to each other, right? I'm talking about this guy, right? So this is same, okay? So, okay, let me do it. Your solution curve yt is equal to inverse Laplace transform of ys, which is inverse Laplace transform of 1 over, we know about that, right? Can I write directly? That is exactly sine t, right? But second one, since we have e to the minus pi, what I'm talking about table number 13, right? Okay, which is u pi over 2t and we need h of t minus pi over 2. We already found h of pi over, h of t, right? That's exact sine t, right? Then we can apply. It is equal to sine t plus u pi over 2t and sine t minus pi over 2. This is the answer, okay? So like, as I told you, like on your online homework, the question asks you to write this one as the piecewise defined function. And as I told you, that is easy. For this case, there's only one point, right? Which is pi over 2, right? So we're gonna have like uh, two interval, right? First one, if your t is between 0 to pi over 2, which means like, u pi over 2 t is equal to 0 because like your t value is less than pi over 2, right? This is 0, then you could have like on the first part only. That's it. But what about the second one? If your t is bigger than or equal to pi over 2, then this is equal to 1. Then you could have like sine t plus sine t minus pi over 2. Hmm? Okay, that's it.